So we're going to talk about mixed fractions, mixed numbers, adding them with like and unlike denominators, and I hope we will get to some word problems. And just as a reminder, when we're talking about fractions, we're talking parts of a whole. So if I have a box and I divide it like this, I have 1, 2, 3, 4, 5 parts. The whole piece is 5 parts. Now let's say I just need to take maybe 2 slices of that. So I want this slice and this slice. Then that is 2 parts over 5 parts, which is the whole. And of course, you may have heard we call this the numerator. And then this one on the bottom we call the denominator. So just as a review, when we're adding, for example, 2/5 and 3/5, it's pretty easy because I can just add them and keep the number on the bottom. It's still 5 parts to the whole, and then I can add the top. So I would add 3/5 plus 2/5 equals 5/5. Any number over itself is all of the parts over all of the parts, so that's equal to the 1. That's one whole. It doesn't matter if it's 6 over 6 or 7 over 7 or 100 over 100 or 1,000,000 over 1,000,000. If the numbers on the top and the bottom match, then it's 1. If the number on the top is greater, let's say I have 3/5 plus 4/5, I'm still going to add the numbers across on the numerators. I still have the same number of parts to the whole, so that doesn't change. But now my numerator is greater than my denominator. What does that tell me? Well, it tells me that I have more than 1. Because what I have, if I draw it out, I have 1, 2, 3, 4. I have 5. And then I have something else divided into fifths. And I have 2 of those. So I have 3/5, 1, 2, 3, plus 4/5, 1, 2, 3, 4, equals 7/5. We don't normally write that. That's an improper fraction because it can be changed into a mixed number. So the mixed number is going to be, we're going to get rid of the 1, so we're going to subtract. This is going to be 1, and then this is going to be 2/5. So a mixed number is a fraction written with a whole number. So I have a whole number plus the fraction. Okay, if you are joining me, it's 9:05. Go ahead and write your name in the chat, your first name only, and your school location. So let's look at some examples of adding mixed numbers. Just look at this first example over here. We'll look at this right now. So in order to add 1 and 2/5 plus 3 and 1/5, I add the fractions first, and I have 3/5, and then I add the whole numbers, 4/5. sorry, 1 plus 3 is 4, not fifths. 1 plus 3 is 4. So then I have 2 fifths plus 1 fifth is 3 fifths, and 1 plus 3 is 4, so my answer is 4 and 3 fifths. Let's look at example number 2. If the fractions don't have a common denominator, they're different denominators here, then we have to get them to a common denominator first before we can add them, right? So the first common denominator between 4 and 3 is going to be 12. I know that because the multiples of 4 are 4, 8, and 12. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. For 3, it's 3, 6, 9, 12. So the first one they have in common is 12. So I make my denominator 12, and I had to multiply 4 times 3 to get to 12, so I also have to multiply the numerator times 3. So I end up with 3/12. I had to multiply the denominator 3 by 4 to get to 12, so I also have to multiply the numerator by 4, and I get 1 4/12. Now I can add. Remember, we add our fractions first. 3 plus 4 is 7/12. And then our whole numbers, 4 plus 1 is 5. So we have 5 and 7/12. Now let's look at this example. Here we have 2 1/2 and 1 2/3. So we have unlike denominators. So we have to get to commons, a common denominator. So the multiples of 2, 2, 4, 6. The multiples of 3, 3, 6. So 6 is our common denominator. Okay? To get to 6 from 2, I have to multiply by 3. 2 times 3 equals 6. So I also have to multiply the numerator by 3. 1 times 3 is 3. To get to 6 from 3, I have to multiply by 2. 3 times 2 is 6. So I have to multiply the numerator by 2. 2 times 2 is 4. So I get 4/6. And now we're going to add the fractions first. 3/6 plus 4/6 is 7/6. Now that's interesting because we've already said that if the numerator is more than the denominator, then it's an improper fraction. And we need to make it proper. But let's go ahead and add our whole numbers first. 2 plus 1 is 3. And then we're going to regroup so the fraction is less than 1. So how I regroup that is 7/6 minus the fraction over itself. That gives me 1. And what I have left is 1/6. That's going to go here. And then I'm going to add, get a different color, maybe it'll be easier to see. I'm going to add this 3 and this 1 to get the 4. Okay, let's try another one. Let me come down here. Let's try number 1 here. Well, we'll try 1, 2, and 3. Okay, I'm going to talk through it again. So our first step is to check to see if the denominators are the same. They are! Yay! So I don't have to do anything special except add the fractions, and then I add the whole numbers. Now here I can actually reduce, because 2/4, I can divide 2 into 2 and get 1. I can divide 2 into 4 and get 2. So 5 1/2 is our answer. Let's look at number 2. If you're watching and you have a question, just put it in the chat for me. 6 1/5 plus 3 2/5. So step 1, we're checking the denominator. We have fifth and fifth, so we're good to go. The next thing we'll do is add the fractions. 1/5 plus 2/5 is 3/5. Then we add the whole numbers. 6 plus 3 is 9. I can't reduce 3/5. It's a proper fraction, so I don't have to do anything else. It's all done. Here's another example. We have a common denominator. It's 2. We don't have to worry about changing anything. 1/2 and 1/2 is going to be 2 over 2. And then the whole numbers, 1 plus 3 is 4. Well, we know that that is equal to 1. So 4 plus 1 is 5. Okay, let's go a little more complicated again with these that have different denominators. I have 3/5 and 2/3. So my first step is to find the common denominator for 5 and 3. Well, if I had to write it out, if I don't know, I would say 5, 10, 10, 15, and then 3, 6, 9, 12, 15. So here it is. So we're going to make the common denominator 15. How do I get to 15 from 5? I multiply times 3. So I have to multiply this times 3. 3 times 3 is 9. How do I get to 15 from 3? I multiply by 5. So I have to multiply the top by 5 also. Whatever you do on the top, on the bottom, you have to do to the top also. So here we have 10. Now I can add, and I get 19/15. I add my whole numbers, and I get 4. Now we notice that this, the numerator, is more than the denominator. Since the numerator is more than the denominator, I need to figure out how many wholes I have. So a whole for 15 is going to be 15 over 15. One whole is 15 over 15. So if I take 15 over 15 away, I end up with 4/15. And this, which is equal to 1, I'm going to add to this. So I end up with 4 plus 1 plus 4/15, which is going to be 5 and 4/15. Let's get that up a little bit. Why don't I give you 2 minutes to try this one by yourself, and then I'll go through the answer with you. Again, if you're watching, please sign in so that I can give you credit for attending. Okay, you should be done. So the common denominator between 4 and 3 is 12. We saw that earlier, but you can always just list out the multiples and find out what it is. 3 times 4 is 12. 2 times 4 is 8. 4 times 3 is 12. 3 times 3 is 9. I add my fractions. I add my whole numbers. 8 plus 4 is 12. I see that I have a numerator that is more than the denominator, so there's at least 1 in there. So I subtract 1 to see how many I have, and then I only have 5/12 left. So this is just 1. And then I add 12 plus 1 is 13, and then I bring over my fraction. Okay, let's look at this one. I have different denominators, but 8 is a multiple of 4, so I know that the common denominator is going to be 8. So I only need to change this one. 4 times 2 is 8, 3 times 2 is 6. So I'm going to add 1/8 plus 6/8, which is going to be 7/8. And then I just add my whole numbers and I get 14. Okay, so here in number 7 we have a slightly more interesting problem here. There's nothing here. What does that mean? What do I do with that? Well, it means that I have 0/5. There are no parts here. 0. Looks like a 6 on the screen, but it's a 0. 0/5. So 4 plus 0 is 4, and I just bring it down, 4/5. And then all I need to do is to add my whole numbers. And there you have it. All right. Now here, you have to find the common denominator of 6 and 8. So if I go 8, 16, 24, well, I know that 24 is also a multiple of 6, so I can go 6, 12, 18, 24. So my common denominator here is going to be 24. My least common denominator is going to be 24. To get to 24 from 8, 1, 2, 3, 8 times 3 is 24. So I also have to multiply the numerator by 24, and I mean by 3, sorry, and get 15/24. And for this one, it's 6 times 1, 2, 3, 4. 6 times 4 is 24. Multiply 5 times 4 equals 20. So I get 15/24 plus 20/24, which is going to be 35/24. So that's improper. We already know that's improper. Add my whole numbers is 4. Since this has a numerator that is more than the denominator, we're going to subtract 1, which will be 24/24. 35 minus 24 is 11. Remember that we have this 1 here that we have to add back in to the 4. These two have to go together. So I'm going to end up with 5 and 11/24. I don't see any questions, so we'll keep going. The last one here on this page. What do we have here? Do we have the same or different denominators? We have different, which means we're going to have to first find the least common denominator. Well, 8 is a multiple of 4, so that's easy. We know it's going to be 8. 4 times 2 is 8. 1 times 2 is 2. I don't have to do anything here except bring it over, since we're already on eighths. So 2/8 plus 5/8 equals 7/8. And then add my whole numbers, 8 plus 3, and I have 11. So how do you feel? It's not as scary as it looked at first, I hope. I want to do one more set of these and then we'll look at some word problems. I don't know which worksheet I want to do. This one looks easier. We'll go with the easy one for today. Okay, so same rules. We're doing the same things. First step, do we have common denominators? No, we have a 3 and a 9. So we have to find the least common denominator. The least common denominator in this case is going to be 9 because that is a multiple of 3. So I'll just bring that over. And then 3 times 3 is 9. So 2 times 3 is 6. And I have 6/9 over 5/9. Then I'm going to add those fractions together. I'm going to add my whole numbers together. 12 plus 13 is 25. Now this is an improper fraction because 11 is more than 9. Anytime the top is more than the bottom, it's an improper fraction. It tells me that there is more than 1 in the fraction. So what I want to do is take out 1. 1 in this case is represented by 9 over 9. 11 minus 9 is 2. But we can't make this 1 just disappear. We have to add it back into the whole numbers because now this is equal to 1 and I have to add that back to the 25. So 25 plus 1 is 26, and then I can bring the 2/9 over. Okay? Here's one of those where I don't have a fraction on the second half, which means this is 0. Since this is 0, I know I can just push this all the way down, 5/8. And then 6 plus 3 is 9. Super easy. Okay, let's go on to number 3. 9 and 3 are different, but 9 is a multiple of 3, so we'll put 5 over 9. 3 times 3 is 9, so 1 times 3 is 3. Remember, I multiply by 3 to get to 9 here. I multiply 1 by 3 on top as well. 5 plus 3 is 8. So it's 8/9. And add my whole numbers. 9 plus 4 is 13. I hope this is getting easier. I have different denominators. First step, check the denominators. 8 is a multiple of 4, so I know that we can use the 8. So I'll just put the 8 over here, 7/8. 4 times 2 is 8. 1 times 2 is 2. So 7 and 2 is 9/8. Add my whole numbers. 1 plus 4 is 5. But this is an improper fraction because it's 9 is more than 8. So if there's more on top than on bottom, then we have to get rid of at least 1. And 1 is going to be represented by 8 over 8. That means I have 1/8 left. I can't make this 1 disappear. I have to add it back over here. So I end up with 6 and 1/8. Bringing that fraction back over. All right, again, we check for the denominators. They are different. 4 is a multiple of 2, so we know that that's okay. We can use the 4. 2 times 2 is 4. 1 times 2 is 2. So that leaves 5/4 if I add those two. I add my whole numbers. 5 plus 2 is 7. Okay. So this is improper because 5 is greater than 4. That means there's more than 1 in the fraction. So I'm going to take out at least 1, represented by 4 over 4. The denominator by itself over the numerator means the whole thing, all of the parts and all the parts together, and that means I have 1/4 left over. I can't make this 1 disappear though. I have to add it back in over here. So I'm going to add the 1, and then I'm going to have 8 and 1/4. Bring the fraction over. We check our denominators on number 6 here. They are the same, so we don't have to do anything special with that. We don't have to find the common denominator because they already are like denominators. So we just add 1 plus 2 is 3. 7 plus 2 is 9. Now, what do we know about a number over itself? A number over itself is 1. So we're going to take that and make it a 1 and add these two. And we get a 10. Hey, Yolanda, it's good to see you. So I'm going to give another example. I don't know which ones you've seen, but we'll just keep going. I think it records so you can watch it again later if you want to. So looking at number 7 here, the first thing we do is check the denominators, and they are different. So I have to find the least common denominator. If you don't know off the top of your head, you can count them out. 5, 10, 15, 20, 25, 30, 35, 40. And in my head, I know that 40 is also a multiple of 8. So we have 8, 16, 24, 32, 40. So 40 is going to be our least common denominator. I'm going to write this one on a piece of paper because it's going to get a little messy, I think. So we have 3 1/5 plus 2 3/8. And the common denominator is 40. So to get to 40 from 8, I had to multiply times 5. So I also multiply the top times 5. So I end up with 15 over 40. Here I had to multiply times 8. So I multiply the top times 8, and I get 8 over 40. Okay? So if I add these two first, we always add the fractions first, we get 23 over 40. That is not an improper fraction because the number is smaller on the top and you can't reduce it any, so it's good to go. All we need to do is add 3 plus 2 and we get 5. I'll give you a minute to try and do number 11 by yourself. Oh, sorry, number 8, not 11, 8. So remember, step 1 is we're checking the denominators. Then we add fractions, add whole numbers, and group and reduce. So we're going to add our fractions. Our denominator is 4. We don't change that. We add the numerators, 3 plus 3. And we add our whole numbers, 5 plus 3. 8. Now this is an improper fraction because 6 is more than 4. So anytime the top is more than the bottom, we have at least 1 in there. To represent 1, we're going to use the denominator over itself. So that's 1, and we'll subtract. So 6 minus 4 is 2/4. This 1 has to be grouped with the whole numbers because it is a whole number. It's 1. So then we have 8 plus 1, 9, and 2/4. But 2/4 can be reduced, right? So 2 goes into 2 one time. 2 goes into 4 2. So it should be 9 1/2. How do you feel about that, Yolanda? Is it easy or hard for you? Somewhere in between. So on number 9, check the denominators. They are different, but 8 is a multiple of 4, so we don't have to change it. We can just carry that one over. We do have to change the 4 to an 8. We got there by multiplying by 2, so we multiply the top by 2. 2/8 plus 3/8 is going to be 5/8. And we add our whole numbers, 9 and 5/8. And we are done. Yeah, math takes some practice. It's kind of like exercising or riding a bike or anything like that. You just have to do it over and over and again until you get used to it. But I want to put it in context here for a few minutes with these word problems, because this is where we get sticky, right? It's the word problems. You do need to know the multiples to be able to figure out what the common denominators are. Okay, so we have a word problem here. Mike has 1 3/4 weeks worth of pay in a wallet. Okay? And 2 1/4 weeks of pay in the bank. How many weeks of pay does Mike have? So we want the total number of weeks he has. That means we're going to add. So I have 1 3/4 plus 2 1/4. We're going to add the fractions first. We get 4 over 4. And then we add the whole numbers, 1 plus 2. We're going to regroup because 4 over 4 is equal to 1. So we're going to put that with the whole numbers. So he has 4 weeks pay. And remember, when you're answering a word problem, you have to give not only the number, but also what you're talking about. Okay, so the next one, it's not too hard. We're making something with spinach. The recipe calls for 1 1/9 cups chopped spinach and 1 4/9 cups of diced spinach. I wonder what diced spinach looks like. In total, how many cups of spinach did the recipe call for? So this is just straight adding because we need a total. We don't need a difference, we need a total. That means to add. So I have 2 5/9. Just adding first the fractions, 5/9, and then the whole numbers is 2. But I have to put what it is, because it's a word problem. 2 5/9 cups of spinach. Number 3 is kind of interesting. Tim bought 1 3/10 pounds of burger and 1 7/10 pounds of sausage at the store. Also, Tim purchased 1 7/10 pounds of chocolate. In total, how many pounds of meat did Tim buy? Now, this happens on tests, so you have to be very aware that there's extra information in this question. They're asking about the pounds of meat. This information about chocolate, I don't need it all to answer this question. I just need to pretend like it's not even there. Because chocolate isn't part of the question, right? It's just 1 3/10 and 1 7/10. So what do we have? Add the fractions first for the total. We get 10 over 10. Add our whole numbers, 1 plus 1. But we know we have to regroup because this 10 over 10 is actually 1. That's a whole number, so we need to put it with the whole numbers. 2 plus 1 is 3. So we have 3 pounds of meat. So read the next one. There's some extra information here too. I'm looking at number 4. Tim did 1 5/12 loads of laundry on Wednesday and 1 2/5 loads of laundry on Monday. 1 7/10 of the loads were colored clothes. What fraction of laundry did Tim do in total? And hey, Lorena. What do you ladies think about this one? What's the extra information here? What do I not need? So the question is asking about in total. The proportion of clothes that were colored is not important. I'm not asking about the colored clothes. I'm asking about the total number of clothes. So this information right here is just extra. So on the GED test or the HiSET, you're just going to get rid of that extra information. Okay? We have unlike denominators, so we're going to have to do a little work. The common denominator for 12 and 5 is 60. So 25 over 60, 24. All right, so 25 60ths and 24 60ths is 49. 24 and 25 is 49. 49 60ths, and then I add my, which is, that's not able to be reduced, and it's also not improper, so we can just leave it alone. So then we add our whole numbers. 1 plus 1 is 2. So we have 2 and 49 60th loads of laundry done. Just let me know if you have a question. We got a couple more to do. I'm trying just this really short class. I'm hoping it'll help. Especially with the math. I know math is always an issue. Okay. Number 5. Joan ate 2 1/3 pumpkins. Wow, she must have been hungry. While Tom ate 1 1/3 pumpkins. And how much pumpkin and total. So there's that meaning. That's always a sign that we're going to add. How much pumpkin did these two eat? So there's no extra information here. We can just do straight math. The denominators, the first thing we check, they're the same, so that doesn't matter. We can just add the fractions. 1/3 and 1/3 is going to be 2/3. And then we add the whole numbers. 2 and 1 is 3. So we get 3 and 2/3 pumpkins. Okay, Lorena and Yolanda, I'll give you just a few minutes to try and do number 6 on your own before I talk through it. You don't have to put your answer in chat. You can just let me know when you're done. So have you gotten an answer? Okay, I'm going to guess that you did. So let's go ahead and look at it. We're looking for in total, which is our key word here. In total means to add. So 1 and 1/2 and 1 and 1/2. 1/2 and 1/2 would be 2/2. That's equal to 1, right? So we're going to add our whole numbers. 1 plus 1 is 2. And then we're going to regroup this by adding it into the whole numbers. And we get 3 cups. So here's another one where they gave us some extra information. Move this camera so I can get here. Okay. We just have a few more to go. So in number 7, we have Benny picked 1 3/10 buckets of limes, and Fred picked 2.5 buckets of limes. Benny ate 1 1/3 limes. How many buckets total did they pick? So we're looking for a total, so that means to add, but we don't want to add in how much he ate. That's not what they're asking. They're asking about what they picked, right? So I'm going to just scratch out that information. If I were doing my GED test, I would just scratch it out so it doesn't confuse me. Then I'm going to be looking at this. First step is to look at the denominators. They are different, but 10 is a multiple of 2, so we'll use that. So we'll have 3/10 plus 2 times 5 is 10, so 1 times 5, 8/10. Now that one I can reduce because they're both multiples of 2. So 2 goes into 8 4, 2 goes into 10 5 times, so that's 4/5. And then I add my whole numbers here. 1 plus 2 is 3 and 4/5 buckets. Remember, when you're doing these word problems, we have to have what they're asking for. Oh, yeah, no, it always happens, Yolanda. I was hoping that this would be less of a draw than Zoom on your devices, which is why we were trying it. If it doesn't work, we'll just stick with Zoom. But in case, you ladies can let me know how you feel about it at the end of the lesson. I know you came in a little late, but at least it records, so you should be able to watch it again, which is nice. Okay, here's Benny again. Benny picked a bunch of limes, and now he has to read some books. So in number 8, Benny has to read some books for school. Benny read 1 and 5/6 books on Saturday, and 1 and 1/12 books on Sunday. How many books has Benny read? Okay, so I'm looking for the total number of books. It doesn't look like I have any extra information, so I'm just going to add. I look at my denominators. I have 6 and 12. Those are different, but 12 is a multiple of 6, so we can use that. So we'll have 1/12 plus 6 goes into 12 2 times, so I'm going to multiply 5 times 2, and I get 11/12. That is not an improper fraction, and it can't be reduced. So we're also going to do 1 plus 1, the whole numbers, and then we'll have 2 and 11/12 books. A lot of people, Yolanda, have that problem. We're a rural county. Well, we serve 3 rural counties. So I'm just trying some different things to keep you guys studying until we can get back into classrooms. And I'm aware, very, very aware, that the internet in some of our areas, even the cell phone service, you have to go outside and talk on the cell phone outside. So we're just trying some different things to see what works. That's why we tried the WhatsApp class, because that's less of a draw on your internet and your data. But we thought we would try this and see how it works. Okay. Number 9, Mary planted 1 4/9 rows of radishes and 1 1/3 rows of turnips in a garden. So there's that in total, which is a clue for adding. How many rows of vegetables did Mary plant? First step, we look at the denominators. We have 9 and 3. Those are different, but 9 is a multiple of 3, so we can use that. So we'll go 4 over 9, and then we have to change the 1/3 to a 9th. 3 times 3 to get to 9, so we multiply the top times 3 too. Whatever we do to the bottom, we have to do to the top. So then we get 13/9. Add our whole numbers. 1 plus 1 is 2. But 13/9 is improper because 13 is more than 9. That means I have at least 1 here. So I want to get rid of the 1 by subtracting 1 in the form of 9 over 9, the denominator over itself. So then I subtract. I have 13 minus 9 is 4. So I have 4/9. But this 1 has to be regrouped. I took it out of here. I have to put it somewhere else. So I'm going to take that 1 and put it over here to give me 3. So I'm going to get I'm hesitating because my answer sheet has a different answer, so I'm checking my math here. Okay. This in the 9ths would be 3/9. Oh, I see. 3/9. 1 times 3 is 3, not 9. Okay, so that would be 7/9, and then I'm fine. Okay, see, it's so easy to make a mistake. That's why I prefer to do it on paper, because then I can use as much space as I want, and I can keep following. So I'm going to do this one again on paper. 1 and 4/9 plus 1 and 1/3. So then 9 is a multiple of 3, so I can use that. And then coming over here. And this is where I do this little trick. 3 times 3 is 9. 1 times 3 is 3. Maybe a little slower, but it makes it less likely for me to make a mistake. So 2 and 7/9 rows of vegetables. Okay, last one. crooked to me. All right. Melanie completed 1 3/10 crosswords on Saturday and 1 1/8 crosswords on Wednesday. She also did 1 1/16 of the jumble puzzle. In total, what fraction of these crosswords did Melanie finish? Well, I'm looking for a total, so I'm going to add. You do have to have a little information to know that the jumble puzzle is not a crossword. It's where the letters are like soup. So this information is not anything I need. I'm going to get rid of it. So then I have 1 3/10 plus 1 1/8. Okay. So the common denominator for 10 and 8, if you don't know, you're going to go and do your multiples of 8, and 8 plus 8 is 16, plus 8 is 24, plus 8 is 32, plus 8 is 40. That's what multiplication is. It's just adding 8 plus 8 plus 8 plus 8 plus 8. So here's 40. We know that 40 is a 10, right? 10, 20, 30, 40. So we can use that 40. To get to 40 from 8, 1, 2, 3, 4, 5, I have to do it 5 times, which means I need to multiply the top by 5 as well. To get to 40 from 10, I multiply by 4. 10 times 4 is 40, so I have to multiply 3 times 4 as well as 12. So then I end up with 17/40. That can't be reduced, and it is a proper fraction. We don't have to do anything else with that. We just add our whole numbers. 2, 2, and 17/40 crosswords. Okay, so that is it for the adding mixed fractions. We'll do some different kinds of calculations with mixed fractions next time. But thank you so much for coming, and do give me some feedback if you think this is a good idea or if it's a waste of our time. I want to make sure what we're doing is working for the students so we can get you through your GED as quickly as possible, and we're not losing traction because we're not face-to-face in a classroom right now. I do appreciate so much, Yolanda and Lorena. You guys are always so faithful to come to class, and whether it's WhatsApp or on YouTube, you're just excellent students. Thank you for coming. If you could, if you're still here, just go ahead and say bye so I can record your time.